I think that the online resources really are transformative in the way that I think of teaching. 2001 is the course on mechanics of materials and mechanics of structures. One challenge is to still keep some kind of element of discovery in the course so that students come out of this thinking, hey, that was neat, I didn't know that. Instead of traditional recitations, we have learning sequences. By interdispersing educational videos and then example problems, it actually makes the process of problem solving a little more active. That's also why I run some of the lectures as concept question sessions. We have a set of problems displayed on the screen. So they see the questions, they answer the question on the Google form, then they're asked to discuss the questions and they get to answer again. And then immediately I can show the distribution of answers to the class. And then it becomes more like a class conversation. I think that overall having the problem set interactive online is particularly good because this is a place for learning, and crazily also the exam is a place for learning. The way that works is if you get the green check of happiness, you know that you solved the question correctly, then you are emboldened to continue to work on your problem. Sometimes you get the red cross of doom, and so the online check becomes a tool for them to know if they're in the right spot, but it also gives an opportunity for the person to find their mistakes and correct them. This is an opportunity that traditional resources cannot afford. So I think immediate feedback is a great benefit of online content.
What I found is that the different ways that you can deliver content, whether it's straight lecture, interactive kind of Socratic method, or a video, they each have a role. And so I have different ways of reaching different people to deliver different types of learning. My teaching here is both online and offline. Most of the students that we deal with are either here in residence, they're the typical grad student. Online, it's a much wider range, so they have differing demographics, but they all have the same objective for taking the courses, and that is to better understand the field and to improve their careers or their advancement. So what I do now is my intro each week is a 5 to 15 minute lightboard video. But I found it to be a very effective way to talk about a quantitative topic qualitatively. One thing we've started doing more and more is the interactive polling. That's a great way to get people who are more introverted or reticent to participate. And so we're using technology, interestingly now, to get more of that Socratic method out, getting more of the interactions. Another thing we've started doing for the online courses is to create small interactive tools. And we're hoping these little tools, these little widgets, will make it so people get that instant feedback from them playing, trying to understand the trade-off. So that's our next step. That's the next area where we're going, giving tools where students can learn on their own and then use the class time for that more precious interaction. That's what we're trying to do.
The fact that we can take 20 amino acids and make proteins that do such a diverse range of things means that those 20 amino acids are a pretty cool set of Lego bricks, right?
Michael Yaffe normally teaches the first half of 705 biochemistry. He is part of the Army Reserves, and so he's away now for the second half as part of the digital learning committee that we have in the department. He was saying how he would love to have his students learn how to use PyMol with the goal of having students better understand and visualize the proteins and nucleic acids they were learning about in class, and being able to use a tool that scientists use in research as well.
PyMol, let's have some fun. Let's build something.
So when students are able to use PyMol, they can look at the structures of proteins and nucleic acids firsthand, manipulate the protein in 3D. And you can move it around, you can rotate, zoom in, zoom out. Then when you have 3D glasses, you actually see the three-dimensional structure better. So you gain a lot of information that you can never get in just a 2D picture. Professor Yaffe is very excited about biochemistry, so that enthusiasm is great for teaching this sort of course. As he's writing on the board, everyone in the class really is engaged and paying attention to what he's doing. Every year we're going to continue adding more to what is available. Professor Yaffe can adopt what pieces he likes and what he thinks is fun.
Cool, fun, that was fun.
I'm Eric Huntley. I'm a technical instructor of GIS, data visualization and graphics for the Department of Urban Studies and Planning in the School of Architecture and Planning. This semester we're looking at climate change and housing in Boston. So we're collecting a variety of data sources and students are exploring them in various ways. By and large, students come into this course with no programming experience. We teach data management and analysis with Python. We teach visualization using JavaScript and a number of common JavaScript libraries, which is a challenge. So I do tech workshops once a week, walking through the production of some kind of completed graphic. We do all of our work through GitHub. It really is, I think, a super valuable thing as far as giving students a sense for how an actual project is deployed and developed. It's a scary thing to take a bunch of scripting languages that you're only just learning and make a visualization that is narratively effective. I try to give a lot of room to students to develop their own project proposals while offering enough guidance and enough workshop-oriented technical content that they have some kind of scaffolding that they can climb up. And that's a lot of it.
Today, we're doing something that's really important.
Let me show it to you in one other way. This is PyMole that you will have a chance to use yourself.
I think it's about letting your students feel that what they are doing is of their own design.
So I think the best thing that any teacher can do is just film a video, do a poll, try something, and see if it works.